Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video compares and contrasts using the z-score table with Statcrunch to find probabilities for the standard normal distribution. Let's get started. So we can find percentiles with the z-score table. The percentiles, remember, was all the data values in our data set to the left of the data value of interest. Well, that corresponds to the area to the left, under the curve to the left of the z-score. So we can use the same concept to find percentiles. And let's just look at an example for the 95th percentile here. So that 95th percentile is the same as 95% probability, which is the same as 95% of the area under the curve. So if we just look for 0.95 in our z-score table, we look and we see that it's actually in between two values that are listed here. So that means we're going to have to interpolate to get the value that we need. Fortunately for us, 0.95 is directly in the middle between these two values. So that's going to make getting that value we need for the z-score a lot easier, because what we can do is to get the interpolation, we just reconstruct our column heading for the row that we need. So if we look up top, the number that we're looking for is directly in between those two listed numbers. So that means the column heading that we're looking for is directly in between those two column headings. So 0.045 is directly in between 0.04 and 0.05. This gives us the second part for our z-score. We then add it to the first part, which we get from the side there for that row of interest. And then that gives us the z-score that we need. So we add those two parts together, and that gives us 1.645. This is the z-score that corresponds with the 95th percentile. Sometimes we want to look for the area in the tails of our distribution. We can also use the z-score table to give us this. So what are the z-scores that separate the bottom 2.5% and the top 2.5%? Well, with the z-score tables, you have to tackle this one tail at a time. So let's look at the tail on the right, the area for the top 2.5%. So if we look for 0.975 in our z-score table, because remember, the z-score table gives us the area to the left of the z-score that we're looking at. So this z-score here, to the left of that is 97.5%. So that gives us the corresponding area to the right, which is the 2.5%. So that z-score is marking the boundary for either side there. But the area we're going to see in our z-score table is here to the left. So if we look for 0.975 in our z-score table, that's going to be down here. And then we just look for the row and column headings from our z-score table. So we match those up, add those two parts together, and that gives us our z-score of 1.96. Now we can do the same thing to get the z-score for the bottom 2.5%. We can look up the z-score from that negative half of our z-score table, and we can get the same thing out of there. But we can get there a lot quicker if we just remember that our standard normal distribution is symmetrical about the mean. So the central axis here, it's actually symmetrical about the mean. So 2.5 here on the top is going to be the same as 2.5 here on the bottom. And so we can just flip that over and just say, the z-score is just the symmetrical. So first we can actually use our z-score table. That'll give us the answer we're looking for. Or we can just recall that the distribution is symmetrical about the mean, and we just take the negative of the z-score. So if you do use the z-score table, you're going to find that you come out with a negative 1.96. It's going to give you the same thing, but it's just a lot easier to get there if you can remember that it's symmetrical about the mean. Let's look at how to use Statcrunch to do the same things that we just talked about with the z-score tables. So we can access our normal calculator in Statcrunch by going up to Stat, Calculators, and then selecting Normal. And then once we get And then once we do that, the normal calculator is going to pop up, and it looks like this. Notice the default that pops up is the standard normal distribution. We have a mean value of 0 and a standard deviation of 1. So this is the default setting for the normal calculator, which is really handy. You don't have to set anything up. Typically, when we're using the normal calculator, we want the standard normal distribution. So these default settings are really handy. Note that the area that's shaded underneath the curve at the graphic at the top of the calculator corresponds with the area that's located here. This is the same as your probability. So 1/2, you have half the area shaded. It's the area to the left because we have the inequality sign less than. It's like an arrow pointing to the left. So this graphical display is really nice because it helps you to realize, okay, this is the area that we're actually looking for. You can use it as sort of a check to make sure you're calculating exactly what you want. So then the z-score is just your random variable value here inside the probability. That corresponds with the edge or the boundary for the area that's shaded underneath the curve. So again, don't get the area and the z-score confused. They're related, but they are two separate animals. So your z-score tables are actually all inside Statcrunch when you use that calculator. So let's show you what I'm talking about here. Okay, we're here in Statcrunch, and I'm going to show you how to work the problems that we just worked the old school way with Statcrunch. So first, in order to find percentiles, we're looking for the standard normal calculator. So I go up to Stat, Calculators, Normal. So here's our standard normal distribution. You can see that the mean is 0 and the standard deviation is 1. That's the definition for standard normal. And to find the 95th percentile, it's really easy. The percentile is actually the percentage of values to the left. So the default here of less than is going to be what we want. Put in the percentile, 95th percent. And voila, there's my 1.645 that we calculated earlier with the z-score table. So really is that easy in Statcrunch. The other problem we looked at with the two-tailed areas, that's more easily accomplished with the between function. Although if we want, we could actually look at each tail individually here. Let's actually do that first. Let's look at each tail individually here. So the tail on the left, if I wanted 2.5%, there's my z-score of negative 1.96, which we see right here. That's the boundary here for the region that's shaded underneath the density curve. If I want to get the one on the right, well, I can do it two ways. I can do it this way. This little inequality sign is like an arrow pointing in the direction of where the shaded tail is going to be. So here it's pointing to the right, so that's we get it on the right. There's your 2.5 tail there on the right. Alternatively, I could get the same z-score by looking at the lower 97.5%. It's the same z-score, it's just a different area shaded. Use the between function to get the tails. I can put here the area that's in between the tails. So if there's 2.5 here on the right and 2.5 here on the left, that means there's 5% that's in the tails, so 95% is going to be in the middle. So I put 95 here, and voila, there's my two z-scores for both the tails all in one shot. So that's how you do it in Statcrunch. Hope that helps you. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountAcademy.com. Thanks for watching. I'll see you in the next video.